Hey guys, welcome back to the channel. If you're eyeing that Microsoft Certified Fabric Data Engineer Associate badge, the DP700 exam, you've landed in the perfect spot today. Microsoft Fabric is blowing up right now as this all-in-one analytics platform, and this cert proves you can handle real enterprise data engineering inside it. Imagine building lakehouses, orchestrating massive pipelines, and optimizing everything without juggling a bunch of separate tools. That's what DP700 is all about. Stick with me because we're going to walk through my full prep guide deck, breaking it down super conversationally so you can nail this exam without the stress. Let's start with the big picture. The exam has about 65 questions. You get 120 minutes and you need 700 out of 1,000 to pass. It's split pretty evenly into 3 domains, each around 30 to 35%. Covering implementing and managing analytics solutions, ingesting and transforming data, and monitoring plus optimizing. Questions are scenario heavy, multiple choice, multi-select, even some hot areas and case studies where you have to think like a data engineer in a big company. You might be wondering why the weights are equal. Well, Microsoft wants balanced pros who can design, build, and maintain end-to-end. So how do you prep? First off, grab a Fabric trial. It's free and lets you play without spending a dime. Hands-on is everything here. Reading alone won't cut it. Allocate 40 to 60 hours if you've got some data engineering background. Start with the official study guide on Microsoft Learn. It's got all the skills measured. Then hit the free learning paths. There's stuff on lakehouses, real-time intelligence, warehouses, everything. I always tell people, don't just watch, build something. Create a workspace, ingest some data, run a pipeline. You'll see how OneLake ties it all together with no egress fees. Common traps? People mix up Lakehouse and Warehouse. Lakehouse is for flexible storage with Spark on semi-structured data. Warehouse is pure relational SQL for reporting. Or they forget governance like domains and labels. Exam loves throwing multi-workspace scenarios at you. Mindset shift. Always think, why Fabric? It's unified SaaS, shortcuts for sharing data virtually, medallion architecture built in. Practice exams are your best friend. Udemy, Plug.eye, whatever. Aim for 80% plus. Join communities too. Repost has great discussions. By the end, you'll think in enterprise terms: scale, cost, security trade-offs. There you go. That's the overview. Feeling pumped? Let's dive into the first module next. Let's kick off with the first big topic: workspace configuration and capacities. Picture this. You spin up a Fabric trial, and the first thing you see is create a workspace. Workspaces are basically your containers. Everything lives inside them. Lakehouses, data warehouses, pipelines, notebooks, semantic models, you name it. But here's where people mess up on the exam. They treat workspaces like isolated silos. Nope. All workspaces automatically share the same OneLake storage layer underneath. That means no data duplication, no egress charges when one workspace reads from another's lakehouse. Microsoft loves testing this because it's Fabric's killer feature compared to older Azure tools. Now, capacities. This is super important for both performance and cost. You've got 2 main flavors. The F-Series SQs, like F64 or F128, which are reserved capacity with predictable pricing, perfect for production workloads where you need guaranteed compute. Then there's pay-as-you-go, which auto-scales based on demand and can pause when idle. Exam scenario you'll see: a dev team with bursty jobs versus a 24/7 production pipeline. Go pay-as-you-go for dev to save money, FSKU for prod to avoid throttling. Domains come into play for larger organizations. Think of them as logical groupings of workspaces. Maybe a finance domain containing all finance-related workspaces. Great for governance and applying policies at scale. Exam tip: if the question mentions multiple departments needing separation but shared analytics, domains plus workspaces is your answer. Common trap: thinking you need separate capacities per workspace for isolation. Wrong. Multiple workspaces can share one capacity, and OneLake handles the data unity. Then comes Spark workspace settings and lifecycle. Spark is the heavy lifter in Fabric lakehouses. When you create a notebook or Spark job definition, you pick an environment. That's where you attach custom libraries, like specific versions of pandas or delta R's for compliance. Fabric manages the runtime, so no worrying about cluster provisioning like old Synapse pools are key. Starter pools are free and fast for quick testing. Everyone gets them. But for production, custom pools all the way. You control node size, auto-scale settings, and pre-installed libraries. Auto-termination is your cost saver. Sessions shut down after idle time. But watch out for long-running jobs. Set it higher or disable. Life cycle here means how you manage changes over time. Notebooks and Lakehouse definitions can be version controlled directly in the workspace. Exam loves asking when you'd use custom environments or pools. Answer: regulated workloads needing exact package versions or consistent performance. Version control and deployment pipelines are absolute game changers for enterprise. Git integration is built right in. Connect your workspace to GitHub or Azure DevOps, and you can branch, commit notebooks, Lakehouse schemas, even pipeline definitions. Development happens in a branch, then merge back. But deployment pipelines take it to the next level. Think of them as your CI/CD highway, stages like development, test, production. You deploy selectively, maybe just a new Lakehouse table or pipeline with parameter rules per stage, different connection strings for dev versus prod. Approvals, notifications, the works. Why does Microsoft push native pipelines? Seamless, no external tools needed, and they only move metadata. Data stays safe in OneLake. Huge trap on the exam, thinking deployment pipelines copy actual data between environments. Nope, just the definitions. Decision guidance, small team or proof of concept. Git integration is enough. Large organization with change control, full deployment pipelines every time. Now let's talk security and governance. Pause here because exams hammer this hard. Security starts with workspace roles: admin, member, contributor, viewer. But for scale, always use Entra ID groups. Assign the group once, manage membership centrally, item level permissions let you get granular. Maybe a contributor can edit pipelines but not delete lakehouses. Sensitivity labels from Microsoft Purview propagate across OneLake, classify PII automatically. Row level and column level security in the warehouse for compliant reporting. Auditing? Everything flows to Monitoring Hub and Log Analytics if you connect it. OneLake files themselves. Workspace RBAC doesn't directly control file access. That's handled through shortcuts and the item permissions. Common mistake, thinking Workspace Viewer can read all OneLake files. They need proper shortcut access. For enterprise multi-tenant scenarios, combine domains, labels, and tenant settings to isolate completely. Finally, logging, auditing, and orchestration. Orchestration means coordinating across items. Sure, you can schedule a notebook, but pipelines are better. Trigger a Dataflow Gen 2, then a Spark job, then load to warehouse with dependencies and parameters. Error handling, retries, conditional paths, all native. Monitoring Hub gives you that single pane: capacity utilization, activity logs, who ran what when. Connect to Azure Monitor for alerts on failed runs or high CU consumption. Exam loves scenarios where you choose pipelines for reliable orchestration over individual schedules. There you have it, full walkthrough of Module 1. We've covered why workspaces and OneLake unify everything, how capacities and pools control cost, performance, native Git and pipelines for mature lifecycle, layered security with labels and RBAC, and orchestration that ties it together. We will now jump into Module 2 of the DP700 exam, ingesting and transforming data in Microsoft Fabric. This is another huge chunk, 30 to 35%, and it's where the real data engineering magic happens. We're talking about getting data from everywhere into Fabric, cleaning it up, and shaping it for analytics, all while thinking about scale, cost, and patterns that work in big enterprises. You might be wondering why ingestion and transformation get their own massive domain. Simple: garbage in, garbage out. Microsoft wants to know you can design reliable, repeatable flows that handle real-world messes like late data, duplicates, or streaming sources. Let's walk through it topic by topic, just like we're building a solution together. Ingestion patterns, batch versus streaming. This is foundational thinking on the exam. Batch is your classic scheduled loads, daily, hourly, whatever. You have full loads for initial history and incremental for ongoing changes. Streaming, that's real-time, event-driven. Think IoT sensors or click streams needing sub-second insights. Exam loves contrasting them. Scenario, financial reports refresh nightly, batch all the way. Fraud detection on transactions, streaming with event stream. Key decision, latency requirements. High velocity or immediacy, event stream into real-time intelligence. Everything else, batch via pipelines or data flows. Incremental patterns shine with mirroring. live sync from Azure SQL or Cosmos without custom code. Full loads, still useful for one-off migrations. Trap, assuming all data needs real-time, most doesn't, and streaming costs more in compute. Next is Dataflow's Gen 2 and Power Query. This one's really interesting because it's the no-code hero. Dataflow's Gen 2 use Power Query Online, that familiar M language interface, to pull from 200 plus sources, transform visually, and stage directly into a lakehouse. Why choose it? Business analysts can own simple ETL without writing code. Folding happens where possible for performance. When to pick data flows over pipelines, transformation-heavy, user-friendly flows. Staging always lands in Lakehouse tables. Limits, lower capacities have refresh constraints, so production-heavy lifts go elsewhere. VS pipelines, data flows focus on transform. Pipelines orchestrate multiple steps. Common exam trap, thinking data flows replace pipelines entirely. Nope, they're complementary. Now, pipelines and copy activities. Pipelines are your orchestration powerhouse. Activities like copy, fast data movement, invoke data flow, run notebook, script, even web calls. Parameterize everything, connections, dates, environments, best enterprise pattern, multi-stage pipeline. Copy raw to bronze, trigger data flow or notebook for silver cleansing, load gold to warehouse. Dependencies until loops, error branching, all built in. Why pipelines over individual schedules? Reliability, visibility, retries. Exam scenario, daily incremental from on-prem, pipeline with copy plus incremental logic. Trap using copy for complex transforms, offload to notebook or data flow. Let's talk Lakehouse ingestion, shortcuts and mirroring. This is Fabric's secret sauce. Shortcuts create virtual pointers to external data, ADLS, S3, even other OneLake items. No copy, zero cost, real-time view. Mirroring, automated CDC sync from databases like SQL Server or Cosmos. Tables appear in Lakehouse instantly. Why preferred? Eliminates duplication, supports hybrid scenarios. Decision tree, internal Fabric data, direct load. External or cross workspace, shortcuts. Database source needing live view, mirroring. Trap, shortcuts don't support writes back to source, read only. Exam loves zero data movement scenarios, shortcuts mirroring win every time. Moving to transformations, PySpark, SQL, KQL, here's where you shape data. PySpark notebooks for heavy lifting, unstructured JSON, massive scale, custom ML. Delta Lake commands, merge for upserts, window functions for dedup. SQL and warehouse, pure T-SQL for relational modeling, star schemas, aggregations. KQL and event house, streaming queries like anomaly detection on real time. Handling real messes, late arriving data, delta merge with when not matched. Duplicates, row number partition or distinct. Missing values, coalesce or imputation in PySpark. Dimensional prep, medallion all the way, bronze raw, silver validated, domain aligned, gold business modeled. Exam expects you to organize layers properly. When to choose, large semi-structured, PySpark. Reporting, warehouse SQL, streaming analytics, KQL. Finally, real-time intelligence ingestion. Event Stream is the star here. Ingest from Kafka, event hubs, custom apps, transform inline, filter, aggregate, route to Lakehouse, Event House, or Power BI. Why for real-time? Sub-second routing, built-in high availability. Combined with KQL databases for immediate querying or Activator for pattern-triggered actions. Scenario, manufacturing sensors, Event Stream to Event House for dashboards. Exam trap, using batch pipelines for low latency, wrong choice. There you have it, full Module 2 breakdown. We've covered patterns that scale, tools for every skill level, zero copy tricks with shortcuts, transformation languages for every job, and real-time flows that feel effortless. Now for the final big push, Module 3 of the DP700 exam, monitoring and optimizing analytics solutions in Microsoft Fabric. This wraps up the last 30 to 35%, and honestly, it's where a lot of people either shine or stumble because it's all about keeping things running smoothly, efficiently, and affordably in production. We're talking monitoring pipelines, spotting bottlenecks, tuning Spark jobs, optimizing Delta tables, warehouse queries, and setting up alerts so nothing surprises you. You might be wondering why monitoring and optimization get equal weight to building stuff. Because in the real world, and on this exam, building is only half the job. Microsoft wants data engineers who think long-term, cost control, performance at scale, quick troubleshooting. Let's break it down topic by topic, just like we're debugging a slow pipeline together. First off, monitoring Fabric items, Monitoring Hub is your command center. It pulls together capacity metrics, activity logs, Run histories. Everything from pipeline executions to notebook sessions to event stream throughput. One pane for the whole capacity across workspaces. Why central? Because in enterprise, you can't hop between items manually. Exam loves scenarios like identify why jobs are throttling. Check Monitoring Hub for CU consumption spikes or overload. Connect to Azure Monitor for custom alerts, failed runs, high duration, whatever. Tip, always enable diagnostic settings early. Common trap, thinking item-specific logs are enough. Nope, Hub aggregates for org-wide view. Next, pipeline and notebook monitoring. Pipelines give rich run history, duration, rows processed, errors per activity. Debug mode lets you peek inside without full rerun. Notebooks, execution logs, cell timings, Spark UI link for deep dives. Troubleshooting flow, failed pipeline, check activity errors first, slow notebook, logs for shuffle spills or skew. Optimization here, parallelize activities, use for each instead of sequential dynamic content for reuse. Exam scenario, recurring failures at 2 a.m., monitor run history patterns, maybe source latency. Now, Spark job optimization. This one's really interesting and shows up a ton. Spark in Fabric is managed, but you control the knobs that matter. Partitioning data upfront by date or key avoids massive shuffles. Caching intermediate data frames for reuse. Broadcast small tables for joins. Adaptive query execution, AQE, is on by default. Auto-coalesces partitions, optimizes joins, but skew. Repartition or salt the key. Broadcast hints when you know sizes. Common issues, OM errors, increase executor memory and custom pool. Slow scans, Z-order later. Exam loves, why is this job slow? Answer often data skew or missing partition. Hang on, because Lakehouse and Delta optimization is pure gold for performance. Delta Lake tables run optimized regularly to compact small files into 128 to 256 megabyte chunks. Z-order by frequent query columns, clusters data physically, vacuum old versions to reclaim storage, but set retention carefully for time travel. When to run. After frequent small writes, streaming, or incremental loads. Automate via pipeline. Trap, running optimized too often hurts writes, schedule nightly on bronze silver. File sizing matters. Too small, scan overhead. Too big, parallelism drops. Now, warehouse performance and query optimization. Warehouse is your relational beast, full T-SQL, transactional. Tuning, update statistics often, especially after loads. Indexed views for repeated aggregations. Scaling, manual for predictable, auto-scale for variable reporting. Query hints sparingly, let optimizer do its job. But partition tables if huge, decision guidance, read-heavy BI, warehouse over Lakehouse SQL endpoint, better concurrency. Mixed, direct query from Power BI to warehouse, exam trap, thinking warehouse handles unstructured like Lakehouse, wrong, use Lakehouse for that. Finally, alerting and proactive strategies. Activator is cool, detects patterns in streaming data, and triggers actions like email or pipeline. But classic alerts via Azure Monitor, high CU, failed activities, long durations. Best practice, alert on pipeline failures immediately. Spark memory spills for tuning, capacity nearing limits. Proactive, schedule optimize vacuum, review Monitoring Hub weekly. Scenario, unexpected cost spike, alert on long-running notebooks plus auto-terminate. There you have it, complete Module 3 walkthrough. We've covered centralized monitoring to spot issues fast, troubleshooting flows for pipelines and notebooks, Spark tricks like caching and AQE, Delta commands for Lakehouse health, warehouse scaling and stats, and alerting to stay ahead. Key mindset, monitor everything, optimize proactively, balance cost and speed. This module tests production readiness. Microsoft wants engineers who prevent fires, not just fight them. Tie it back. Module 1 built the governed foundation. Module 2 got data flowing clean. Module 3 keeps it humming efficiently. Go practice. Run a messy Spark job. Monitor it. Optimize with Z-order and vacuum. Check warehouse stats impact. We've made it to the end of our DP 700 series. We've covered all 3 modules in depth, from setting up governed environments in Module 1 to smart ingestion and transformation in Module 2, right through to monitoring and optimizing everything in Module 3. Now let's wrap this up with some top exam tips and a solid summary to lock it all in. Think of this as your cheat sheet for test day, the stuff that turns good prep into a passing score. First big tip, read scenarios fully, and I mean really dig in. Every question is a mini story about an enterprise problem. Identify the key constraints right away. Is it scale they're worried about? Cost overruns, real-time needs, compliance? Microsoft loves throwing in distractors, so pause and ask yourself, what's the primary driver here? For example, if it's massive data volume with semi-structured files, lean Lakehouse. Strict relational reporting, warehouse. Real-time alerts, event stream, and real-time intelligence thought. Next, prioritize Fabric native solutions, especially OneLake and shortcuts over anything external. You might be tempted by old habits like copying data to blobs or using external tools, but the right answer almost always favors no data movement, zero egress, virtual sharing via shortcuts. Why? It's cheaper, faster, and more secure in Fabric's unified world. Exam trap. Choosing a pattern that duplicates data when shortcuts or mirroring would solve it elegantly. Another must. Practice case studies, those multi-question scenarios that follow one big company story. They test how everything connects. Governance from Module 1 affecting ingestion in Module 2, then optimization in Module 3. Do as many as you can. They'll train you to think holistically. Now, why even pass DP700? It validates modern Lakehouse engineering in the unified analytics era. You're not just a data mover anymore. This cert shows you can design end-to-end solutions on a single SaaS platform, balancing medallion architecture, real-time intelligence, security labels, and cost controls. In today's job market, it differentiates you. Companies are all in on Fabric for its simplicity and power. Looking ahead, your next steps are straightforward. Complete the Microsoft Learn Paths. They're free, hands-on, and directly aligned. Then, build an end-to-end project in your trial. Ingest from multiple sources, medallion layers, pipeline orchestration, real-time dashboard, monitoring alerts, the works. Finally, take practice exams until you're consistently over 80%. Official ones, third-party, drill those case studies. There you have it, the full wrap-up. We've gone from workspace foundations to production optimization, always focusing on why Fabric wins. Unified OneLake, native tools, enterprise governance without complexity. You're ready for this exam. Go hands-on, think scenarios, prioritize native. You'll crush DP 700 and level up your career. If this series helped, hit that like button, subscribe for more cert prep, and comment. Did you pass yet? Or what's your target date? Thanks for watching all the way through. You've got this. See you in the next one.